My name's Frank Mayo. I'm president of the Greater Houston Creation Association. We study science with the assumption that God did what he says in the Bible. Of course, most science is done with the assumption that there is no God or anything supernatural. So when we go out and look at science with that open-minded attitude, we start finding all kinds of evidence that indeed what God says in the Bible is in fact true. And we can't answer all questions yet, but the more we look, the more we find, and it is glorifying God. And we hope to do the same. It is wonderful to have the use of this facility tonight. Pastor Dunn, and thank you very much for allowing us to do this. And thank you, Greg Biggerstaff, for making it all work. He does an excellent job, and I'm a little bit envious sometimes. So thanks to everyone. What we're doing these days in the GHCA, and if you don't know, we have a website, Greater Houston Creation Association. It's GHCA-FL1.com. Take a look at it sometime. You can also sign up for our newsletter, which comes monthly, with a couple of reminders that gives background material about the topic that's coming up, like tonight or any other night. So take a look at that, and please do sign up. We can always use more on the mail list. We are currently doing a series on models, geophysical or physical models of Noah's flood. It really happened, and it must leave a lot of evidence. And indeed, it does leave a lot of evidence. Most of society tell you, oh, that's just a myth. It's just a story, a Bible story. We need to get rid of that idea of using the word story to describe anything in the Bible. It's not, it's real. So, we do find a lot of physical evidence. Some of it is hard for us to understand. They're not everything understood. There are questions to be asked yet. And there are several theories about how all of this could transpire in a physical way, in a scientifically understandable way. Of course, God's hand was involved, so you don't expect to have complete knowledge and understanding on a human level of everything. But we can see and observe a lot of physical evidence. So let's learn to understand that more and more, and it will glorify God and bring us closer to him. That's our goal. There are two main theories. One of them is called the hydroplate theory. It was developed by a gentleman named Walter Brown, who is a PhD mechanical engineer. I believe he taught in the Air Force Academy for many years. And he is a brilliant gentleman, and he came up with some brilliant ideas about the initial conditions that might have existed before the flood. So this is really intriguing. And there is some evidence, a number of things that do fit in with that. Again, there's questions not unanswered yet, and there's more work to be done. There's another theory called catastrophic plate tectonics, developed by another brilliant gentleman, PhD geophysicist, worked with Los Alamos National Lab for a number of years. It seems to describe a number of the things that we see inside the Earth with what is geophysical type of CAT scans. Gives you slices of images in turn. Again, that's not complete and perfect, but it is a really intriguing thing to follow and talk about. And compare these two. Can they possibly be combined sometime? I don't know, but it's worth talking about. When we start talking about different things like this, we always learn to understand more than we did before. And that is a very, very good thing, a very good way to go about it. So we'll have a presentation of hot plate tonight. Next month, we'll have a presentation on catastrophic plate tectonics. And then the third month, we'll have a little bit about another one that's kind of, some people still think on because they've never heard anything other than canopy theory. Well, that has gone, and everybody needs to understand that. Then we will have a roundtable discussion between the main players in all of this and see if we can all voice some of the things that come out of these presentations, the questions and things in our minds and our hearts possibly. So that will be a great experience. We'll all learn from that. So come see all three presentations. Don't stick with just one of them. And I think you'll greatly benefit. So for right now, I'm going to call up our first speaker, Mr. Brown Lauer, who is a specialist in this area. And thank you for being here.
All right. Well, thank you very much. I do appreciate that. And again, a big thank you for this organization, this church, for Pete and Diana for flying me in here to give this talk, and also for Frank, because he's doing something that is quite impressive. He's doing something that Dr. Thomas Chamberlain, he'd be really impressed with. He said you should always have multiple working hypotheses. So then you can sharpen your analytical skills. You can compare and contrast. You can reduce biases. He says otherwise you just memorize and conform. And so I do thank you, Frank, for allowing this venue to look at two different theories, and hopefully we'll move science down the lane. And then the other one, I'm from Minnesota, and it's with great pleasure I can come here and say thank you, Texas, along with Florida and South Dakota, who led us to freedom back when they were trying to lock us up. But that battle's not over. I don't know if you heard about what happened on Saturday in the middle of the night. They gave Tetros the authority to call the next pandemic. And so you can check that. So we need to be aware of what the powers that be are doing. And you just need to be aware. And also Washington, D.C., the Department of Education, they're telling us how to think about the past. They give us a blind chance, random collisions of atoms perspective of the past with the Big Bang and evolution. And that's with their Department of Education, and that's the only way you can look at it. But their perspective is all wrong, because these are just screenshots from secular journals. Researchers want to know, unexpected, fossil oddity, long-standing puzzle. I totally didn't believe it. It shouldn't exist. Scientists puzzled. Double-ended mystery, surprising features, unanswered questions, hard to believe, world of surprises, major mysteries, wrong directions. Puzzle scientists, puzzled students. Why are they puzzled? Because they have the wrong perspective of the past. Blind chance doesn't bring us this. A creator brings us this. And so if you start with a secular model, you're going to have mixed up ideas. And I'm here to present a biblical model. And does anybody know what that is? Anybody? Brianna probably does. Yeah, what is it, Brianna? Yeah, a bear climbing up the other side of the tree. Can you see that now? Okay, yeah. And so there were some seemingly unrelated data points there, lines and circles, but then you give it a picture and it comes together in one coherent picture. And that's what we're going to do with the hydroplate. Because we've got answers to scientific problems, and we had all those, there's a lot of them. We're going to go through a lot of those problems. And we had our very first hydroplate conference last year in September. And you can watch it online at hydroplate.org or on Rumble or on YouTube. And we had 3 PhD scientists speaking. And one of them was a professor of astronautics from the U.S. Air Force Academy. So there's some very well educated, very prestigious people who think this is a good theory. And so the hydroplate has the answers, but if you don't know what the questions are or what the mysteries are, it's not going to matter. So we're going to run through a few of them. There's the there's the scientific problem one. Okay, And let's see, what mechanism would cause a large volume of low-standing continents to rise rapidly a mile in the air? This is the plateau mystery. We have then a double-ended mystery. For the Colorado Plateau seems to have grown downward at the same time that its emerged part rose upward. So that's a double mystery. And then why is the crust missing in the mid-Atlantic? This is from Science Daily. It says the Earth's crust missing in the mid-Atlantic. Mantle is exposed on the seafloor, and it was as if it was never there. So then how and why? But if it was there and torn away, if so, how and why? So they don't know. And what caused the Ice Age? And once it started, why did it stop? And this is from Nature. They're puzzled. Perhaps the longest standing puzzle in the earth sciences is what caused the northern hemisphere's ice sheets to come and go. And how do redwood trees grow where it's dark 4 months of the year? This is from Science Daily. Fossil oddity, giant redwoods near the North Pole. They say they're 45 million years old. And it was covered in a forest in the permafrost. I don't buy that one. And it's a challenging mystery, because how can trees grow when it's dark 4 months of the year? And then it said these fossils are chemically preserved at a level you usually would expect to see in something that's only 1,000 years old. Not millions, 1,000. Scientifically, that's what it shows. And then Discover Magazine talks about the greatest unanswered questions of physics, and number 3 is, how were the heavy elements from iron to uranium made? They don't know that. And Walt Brown doesn't think that there was uranium during creation, because God said everything was very good. Is it good to have uranium, which can cause birth defects? And so he thinks it was made during the flood, and that's just foreshadowing a little bit. This is from Science. It says, we're all made of star stuff. The problem is physicists aren't quite sure how stars did it. And then why is the moon rusting? This is from NASA. The moon is rusting, and researchers want to know why. While the moon is airless, they find hematite up there, a form of rust that normally requires oxygen and water. That has scientists puzzled. It's very puzzling. The moon is a terrible environment for hematite to form in. Yeah, if you believe in blind chance and random collisions, yeah, it's a terrible environment. But if you, and that's this, I totally didn't believe it. It shouldn't exist based on the conditions present on the moon. But the hydroplate will answer it. Then why are rounded boulders on comet 67P? Because when things slam together in space, they're going to have jagged edges. The only way you get rounded things is if it's going through a fast flow of water before they go up there. Well, how could that happen? And this is from Science. It says one of the most surprising features discovered is nodules. They call them dinosaur eggs or goosebumps. Rounded boulders on that comet. And this comet, this is Science comet, close-up reveals a world of surprises. I find it hard to believe that at the present time 67P was originally homogeneous. Comet-forming regions of the early solar system were more turbulent and chemically diverse than theorists have thought. So the theorists were wrong. You know, one experiment is worth 1,000 expert opinions. Just remember that one. And how do you get peanut-shaped asteroids? You know, this is a major mystery, how two objects, each the size of skyscrapers, could collide without blowing each other to smithereens. This is especially puzzling in a region of the solar system where gravitational forces would normally involve collision speeds of 4,500 miles an hour. Yeah, how is that going to happen? Then you got these peanut-shaped asteroids, and one of them has a moon. How did peanut-shaped asteroid 624 Hector get a moon? And it talks about it's a mystery. But they're found that the asteroid could be captured and produced. The formation of the system made a dual primary, and a small moon is still a mystery. Catching a moon is really difficult, because if two objects are coming together, they're either going to slam into each other or they're going to slingshot around each other. Catching a moon is really, I mean, they can't even explain how we got our own moon. They got 4 theories, and none of them work, so one of the professors says the best explanation for the moon is observational error. It doesn't exist. And then he's kind of tongue-in-cheek saying that. And why is Naiku orbiting backwards? It's a weird orbit, puzzles scientists. And from phys.org, beyond Neptune, a chunk of ice is orbiting the sun in the wrong direction. That's because your perspective of the past is wrong. Okay, those were all secular journals. They all had big questions. Now let's just do some random questions. Mount Everest, this is NASA. What causes a mountain to rise? You know, what's the mechanism, the energy, and the force, and how do marine fossils get way up there? And NASA writes, the presence of limestone and ocean marine fossils at the top of the mountains is one of the key pieces of evidence cited that advanced the idea of plate tectonics. So plate tectonics was put in place to explain the fossils on Mount Everest. So plate tectonics, that's a secular model. Catastrophic plate tectonics is a secular model sped up. It's kind of like evolution is a secular model. And theistic evolution is a secular model with Jesus slapped on it. And so we should be very careful about taking our models from our government, their models. Okay, and how did Mariana Trench form 7 miles below the sea level? How did that happen? And why are trenches mainly in the Pacific and not in the other oceans? And why is it so much different in the Pacific? And why does it have 40,000 volcanoes with table mounts and sea mounts? And how did the mid-oceanic ridge form? You know, that's a 46,000-mile mountain range that circumnavigates the globe at the bottom of the ocean. It'd be the 8th wonder of the world if people knew it was there, but it's buried underwater. And that mountain range is made by stretching it in 2 directions. See, when rock is compressed, it gets a bunch of crinkly, lines, cracks. But when it's stretched, when the pressure releases, you get a straight crack. And this is what you have. You have vertical and horizontal cracks. So it's being stretched in 2 directions. And why are mountain ranges parallel to the mid-Atlantic ridge? And what caused inland seas to form? And I thought, how do you know they're inland seas? On the Gulf of Mexico, the Mediterranean? Because there's a whole bunch of salt at the bottom, along with the Black Sea and the Caspian Sea. Well, how did all that salt get down there? And we were paging through Walt's book, and there's the Gulf of Mexico, and my wife said, hey, that's going to be close to where you're speaking. And I've never heard anybody talk on this. These are the salt layers. This is under the Gulf of Mexico is a single salt layer called the mother salt layer. It is at least 20,000 feet below sea level, 100,000 square miles in area, and 1,000 feet thick. Many tall salt domes have risen several miles above the mother salt layer. Some salt domes are taller than Mount Everest. How does that happen? How does all that salt get down there? And then it says, sediments almost 30,000 feet thick were then deposited on top of the 1,000-foot thick mother salt layer. How did that happen? And this is your salt dome, And so my biggest question in August is, hey, how did all that salt get down there? How did it get all covered with sediment, and then it got to rise through that loose sediment? That's I don't know. That's going to be interesting in August. Okay, and then how did the 90 East Ridge form? That's a ridge that's 3,100 miles long by 120 miles wide, and is perfectly straight. And why does it point at the Himalayas? And then where did all the sediment come from that averages a mile deep on the continents? You ever wondered about that? What eroded all that sediment for the sedimentary rocks? And the ratio, if it doesn't have limestone in it, or doesn't have carbon in it like limestone, the ratio is 65 parts granite and 35 parts basalt. Why more granite than basalt? And basalt's mainly the ocean sediment, the basement rock of the oceans. How did that get on the continents? Tough questions. Okay, and let's see. And what caused it to be so evenly mixed with a cementing agent like calcium carbonate and quartz? Quartz is key. Quartz is in granite. We're going to come back to that. But those sand dunes, are they turning into stone? No, they're just blowing around. The only way they get turned into stone is if it's mixed with a cementing agent. And you've got cementing agent all over the world, turning all this sediment into sedimentary rock. And this is the Zuni mega sequence that goes all over the continent. And I was talking to a student at St. Cloud State, and it's like, there was a worldwide flood. And he goes, he didn't think so. And I said, well, you explain. How do you get a continent-wide layer of sediment? And he said, mudslides. I don't think so. Well, how do you get seashells in the mud then? But these layers, they go all around the world. Tim Clary's doing a great job for ICR looking at the boreholes, and it's like it's all over the world. Worldwide layers of sedimentary rock. And I like how Answers in Genesis explains this. Global evidences of the Genesis flood, and in there, it's talking about the cliffs of Dover and the cliffs of Normandy. These same chalk beds can be traced across France, the Netherlands, Germany, Poland, southern Scandinavia, and other parts of Europe to Turkey, then to Israel and Egypt, and as far as Kazakhstan. Remarkably, the same chalk beds with the same fossils and the same distinctive layers above and below them are also found from Nebraska to Texas and from Alabama and Arkansas to Colorado. And they also appear in Australia. Those chalk cliffs go everywhere, and you can't lay that down with a local flood. And then how do flat layers form under slanted layers in the Grand Canyon? You got slanted layers underneath the flat layers. Why would that be? And speaking of Grand Canyon, why did the Colorado River flow through the plateau instead of around it? Those elevation maps, it clearly should have flowed around it, and yet it flows right through it. How does that happen? And then where did all the limestone come from? Walt Brown, he used to meet with Bob Dietz. He's the guy who coined the term seafloor spreading, so he knows a lot about geology. And they'd meet at Arizona State, and Walt asked him one time, because when limestone forms, it releases carbon dioxide. And there's 60,000 times more limestone on the surface of the earth than in the atmosphere. So Walt asked Bob, where'd the limestone come from? And Bob says, beats the blank out of me. You can't explain it. So there's a lot of mysteries there. And then there's this 5 to 10 ton quartzite rock that got lifted up into the sedimentary layers. How does that happen with your Big Bang theory? And those are two of Walt's grandsons, and don't try this unless you're in excellent shape. I think it's a day or two hike down there. But that's a real hard thing for the gradual, uniform, millions of years thing to explain. And what force crushes granite? This is the Gunnison Canyon, or more specifically the Black Canyon of the Gunnison River. Yeah, those are compression cracks. Remember we talked about tension cracks being straight? These are compression cracks like marble cake. And to give it scale, those are on the top there, those are 5 to 10 foot trees. So this is a lot of granite that got crushed. And this goes for 50 miles. What has enough force to crush 50 miles of granite like that? And then it also did the same thing at the bottom of Grand Canyon. The inner gorge has the same type of compression cracks in the Vishnu schist. And how did mesas, buttes, and spires form? And how did petrified trees form? And how did canyons form under the ocean? These are submarine canyons, and a lot of the major rivers have major canyons cutting through on the continental shelf, but it's below the ocean. The one at the Congo is twice as long as the Grand Canyon. And so how does that happen? And also in Greenland, there's a canyon cut by a river under 2 miles of ice. How'd that happen? And then in Antarctica, they got lakes under 2 miles of ice. How about that? And they're liquid. And if you deny the worldwide flood, you got to figure out a way to cool down Antarctica to make liquid lakes. And that's going to be tough because the average summer temp is less than freezing. Okay, and then this says the South Pole is covered by ice, but fossils show that crocodiles, dinosaurs, and palm trees once lived on that land. How are you going to get palm trees to grow where it's dark 4 months of the year? And then on the other side of the world, up in the Arctic Circle, they find fossils of snakes, tortoises, alligators, badgers, shrews. They can't live in permafrost. How'd they get there? And also those redwoods we talked about, but let's just see the size of them. They're 98 feet to 131 feet long, and they got a 10-foot diameter. Those are big trees. And they ain't growing there if it's dark 4 months of the year. And then what froze the mammoths? The mammoths, it's a misnomer. They call them woolly mammoths, but it's not wool, it's hair. And they don't have erector muscles or oil glands to make it warm, and there's no way they can live in the Arctic. Do you guys get cold noses in the winter here at all? Does it ever get that cold? Okay, well just think if your nose was 6 feet long. It's not gonna work. And also they eat too much. They eat too much, they drink too much. There's no way they're living up in the Arctic. They're a temperate animal. So how did they freeze and how did they get up there? Okay, and what froze the mammoths? Again, this one here was frozen standing up. Any deer hunters out there? Anybody hunt their deers? What happens when you shoot them? They tip over, yeah. And then what do you do? Eat them. But before that, before you eat them, you gut them. Yeah, you take the gut out so that heat goes out of there. That heat's going to destroy the meat. Well, that didn't happen with this one. It still had identifiable food in its stomach and its mouth, and it was summer food. And so it was flash frozen. They figured 150 degrees below zero, and it just, boom, how did that happen? And then how did it get so cold so fast during the summer to freeze them? And then once it froze, how come it didn't thaw out? Tough questions. And then why were there no glaciers in parts of Alaska? If you look in the upper left corner there, that yellow part, that's the land bridge between Alaska and Russia. I always thought it was the Aleutian Islands, that was the land bridge, nice and narrow, but this is big, wide land bridge. And then the brown part up there, didn't have a glacier. So it's the Ice Age, and you don't have a glacier in parts of Alaska or Siberia, where there's permafrost today. You didn't have a glacier during the Ice Age. And how come how can we find stuff from Earth in the comets? You find water, salt, silicates, limestone, cubonite, all that stuff. Oh, cubonite, that's a good one. Let's look at cubonite. That cubonite forms only in the presence of scalding hot water. How do you get scalding hot water in space? And it says liquid water can't reach those extremely hot temperatures in comets' low pressure environment. Indeed, even cold liquid water inside comets will instantly flash into steam. So how are you going to form something in scalding hot water? Then why is there sea plankton found on the outer surface of the International Space Station? Plankton, how does that get up there? And then this one, how does an asteroid get moons? We talked about that. And chondrules, how does that form in meteorites? And you're thinking, what's a chondrule? That's what I thought. So I looked it up. And whatever it is, it's formed at high temperatures. And how the chondrules were melted, however, is not understood. So they're still puzzled based on their blind chance theory. But you have high energy events such as high velocity collisions and splashed about as droplets that quickly cooled and crystallize. So high impacts, quick cooling. What's going to cause that? And then why does Pluto look so young? They figured it would look, that was a prediction on the left, it was going to look all old and beat up, but it looks pristine. Why is that? And then why is the far side of the moon so much different than the near side? Because the far side's pretty white there, there's no lava flows or moonquakes, but the near side, man, look at all those lava flows, that's the dark area. The near side of the moon got pounded. You know, the far side got peppered. There's high density impacts, I think, on this side. And it's counterintuitive because the Earth protects the near side of the moon. And when you throw the Earth's gravity in there, it's going to be really hard to have a direct hit on the near side. And yet the near side is the side that's pounded. And does anybody know where where Earth's oldest rock was found? Anybody know? It was found on the moon. How does a rock get to the moon? And it must just be covered with Earth rocks there because you just picked up at random and brought it back. And yeah, it was found on the moon, and it says it was crystallized about 20 kilometers beneath Earth's surface in a water-rich environment. How are you going to get a rock 12 miles deep onto the moon in a water-rich environment? And then why do nearly all short-period comets go in the same direction as the Earth? Because if the comets came from the Oort cloud, it should be a 50-50 mix. Some going prograde with the Earth, some going retrograde against the Earth, but it's not. It's 97% in the direction of the Earth. So my guess is the comets have something to do with the Earth. Okay, and so we asked a lot of questions and a lot of seemingly unrelated topics, but I submit to you that the hydroplate answers every one of them. Logically, coherently, you say, oh yeah, I can explain that. And so the hydroplate, as Frank mentioned, it was developed by Dr. Walt Brown. He went to West Point, he was an Army Ranger, paratrooper, went to MIT and got his PhD in mechanical engineering. So he's looking at the Earth, there's mechanisms and forces and energy budgets. How is this all going to work? Which is a good way to look at the Earth, I think. And then he ran the Benet Military Lab where he had dozens of scientists, PhDs working for him, and like 100 scientists. So he's a really sharp guy. He did, the U.S. Air Force Academy wanted him to teach there, so he did. And yeah, it's just phenomenal. And that's not what impresses me about him. I don't care about the letters behind your name. I don't care what you've done here or done there. He makes accurate predictions. Some of them are astoundingly accurate predictions that just drops the jaw of the seculars. So I find, and at St. Cloud State, I was invited into a class, believe it or not, to share my thoughts. The professor said, you got 15 minutes once the kids get here. And so I said what I did, and it was done in 10 minutes. Any questions? And the professor said, well, what would you do if you were king of science for a day? I said we'd put all the theories on the table, and we'd focus on the one that makes accurate predictions. Plus, we won't teach belief systems about the past, like the Big Bang and evolution. That's got nothing to do with science, because science is observation and testing. And so then there's Walt Brown. And the 8th edition, it used to be a $30 book. The last one on Amazon went for our $280. And we got 16 of them here tonight for $50. So if anybody wants to get one that you can hold in your hands, this is the 8th edition, copyright 2019. Or no, it's 2009. The 9th edition, copyright 2019, is on DVD. I can show you how to download a PDF for free. Okay, but it's neat to have the book because then you can go hydroplate surfing. Because you look about that and it'll give you a reference to another thing and all the ideas kind of flow together. And so this is available for $50. I think it's for a limited time. And this astronaut thought so much of it, he brought it into space and took a picture of it on a disc, and then he presented it to Walt Brown. So there's very highly educated people who understand this. And I went into St. Cloud State, and I went to the Earth Science Department, and I met a professor, and I said, you guys don't have a theory for Grand Canyon that works. Do you want to see a theory that works? And to her credit, she said yes. So I let her have my book for at least 6 months, and then we got together, and we talked about it for about an hour and a half, and she said, if the assumption is true, the science works. I just don't believe the assumption is true. Okay? So what I'm about to show you has been rubber stamped, or it's been verified by a college professor, if the assumption is true. So what's the assumption? At least half of the ocean was inside the earth at one point in time, 60 miles deep under granite. That's the only assumption. How it got there is not part of the theory. So just think of the earth as a big apple with the apple skin 60 miles thick, made of granite, and then there's a layer of water about a mile thick, and then there's basalt underneath that. That's it. And then let the laws of physics go at it. How do you do that? You throw the moon in there, because the moon tugs on the earth twice a day. You get high tide and low tide twice a day. Well, back then it's tugging on the crust of the earth, and the crust wasn't broken into plates like it is today. It was just the crust. So the crust stretched and compressed, stretched and compressed, stretched and compressed, and generated heat. Like if I had a wire up here, bend it back and forth, it's going to get hotter and hotter. That's what happened with the crust. The heat went into the water. The water got hotter and hotter. And it wants to boil. It's hot enough, but there's no room to expand, and it can't boil. So at 705 degrees and 3,200 psi, it becomes supercritical water. And they understood this in 1822, but they didn't know what it was. You know, when you put pressure on top of the lid, you know, it'll boil at 212, but if you cap it and keep it pressurized and keep getting it hotter and hotter and hotter, again, 705 degrees, 3,200 psi, it's supercritical. What is it? And then in 2005, they finally figured it out. They said it's both. It's water and vapor. It's microscopic drops of water suspended in air. This is when the liquid density equals the gas density. And whatever it is, you know, that's what it is, and it dissolves things like crazy. That's the key. So it's dissolving the granite above, and remember there's quartz in the granite, and it's dissolving the basalt beneath. And it's putting together all these minerals like limestone and chalk and quartz and salt, and quartz is a key one there. And so and then I think it precipitates out of the water at about 800 degrees, the salt does. So you're getting these layers of salt and minerals at the bottom of the subterranean chambers. And so those are building up and building up. It's getting hotter and hotter. The crust is getting weaker and weaker, and pretty soon there's over 300,000 psi in that subterranean chamber. And when there's a crack on the crust of the earth, it's going to erupt out of there. It's going to go in two directions at 2 to 3 miles per second, and it's going to circumnavigate the globe in a few hours. And the water's just going to erupt out of there from over 300,000 psi to almost zero at the atmosphere. It's just going to poof. And that's how it could rain for 40 days and 40 nights. And then people say, well, if that happened, wouldn't it leave a mark on the earth? And the answer is yes, it did. It's called the Mid-Oceanic Ridge. That's what happened. That's the mark it left. And if you see that circle there, Walt thinks that's where the crack ended, because the crack from the Pacific got there first, and then the crack from the Atlantic got there and hit that and stopped going. So you run the movie backwards, he thinks it started up in Alaska. And then it's just going to go all the way around, and it's going to just start erupting. It's just hypersonic water just shooting up with tremendous force. And now you got two 60-mile cliffs, right? And on Earth, you can only have a cliff 5 miles high because it's going to crush what's underneath. It can't support over 5 miles. So now you got 60 miles cliffs, and there's 2 of them. And they keep eroding, and you'll notice that it's eroding on 2 sides of the granite. On the bottom of the granite and on the side of the granite, but only one side of the basalt, on top of the basalt. And that's why I believe that there was the ratio, 65 parts granite to 35 parts basalt. And that's where you're going to get all the sedimentary rock all over the layers. And then you get all this sediment there. Well, how come they're sorted so well, like at the Grand Canyon? It's just these pure layers, knife edge. And Walt Brown says that, and Bob Enyart too, liquefaction. During the flood, there weren't any continents, so there's nothing to break up the tides. So you got these huge waves going across the continent. It could be 200 feet high. So there's 200 feet of water pushing down. That's a lot of pressure. You know, that'll pop your ears, I suppose. And then when the trough goes by, the pressure is released. So the water comes out of the sand, and then the next wave pushes it down, and comes out, pushes it down, and that could sort it out. It's called liquefaction, and that's how you get layers all over the earth. Okay, so now the 2 60-mile cliffs are getting wider and wider and wider and wider and wider apart. And then pretty soon there's nothing pushing down on the mantle. So the mantle bulges and the continents start sliding. And that's why the Earth's crust is missing in the mid-Atlantic. It slid away, it eroded away, and then it slid away, and then the continents fit perfectly. They show you Pangea, but there's a lot of problems with that. They have to shrink Africa 30-some%. They have to twist things, and no Central America. But if you just line up the continents around the mid-oceanic ridge and allow a few hundred miles for erosion, now it fits perfectly. So that's why the crust is missing in the mid-Atlantic, and now you got these continents sliding on supercritical water, which I think is 30-some% more, has more viscosity than regular water. So it's just grease lightning. The continents are sliding, and it's like if you had a train track and you lift it up, the train's going to start rolling. And that's what's happening with the continents. You got North America and South America going to the west, and you got Africa and Europe going to the east, and they keep going until they meet resistance or run out of water. And then they're going to buckle up. You know, it's like a rug going into a wall. It's going to buckle. And that's how the mountains formed. That's why the major mountain ranges are parallel to the mid-Atlantic ridge. Okay, and you'll notice that the Rockies are twice as wide as the Andes, and I think it's because the Rockies slid over the mid-Atlantic ridge. And then there's a lot of friction there. There's just a lot of friction, a lot of heat, a lot of melted rock, a lot of lava, and it's going to make our coal and oil and metamorphic rock like the marble and the diamonds. And by the way, all that stuff has carbon-14 in it, proving that they're not millions of years old. If you find carbon-14 in anything, it's less than 100,000 years, and they find it all these things that are supposed to be millions of years old. And then you've got these folded mountains up in British Columbia, and these are layers, you know, they're curved rocks. And you can't bend rock, it's going to break. I don't care how strong you are. And so what happened here is the layers of sediment were laid down, and then it buckled up while it was still moist, and then it turned to rock. That's how those were formed. And what force crushed the granite in the Gunnison Canyon? Well, a continent's sliding, and then it stops on this side, but this side is still going. So that's how you're going to be able to crush 50 miles of granite for that. I mean, that's a lot of pressure. And that's how it's going to crush in Grand Canyon, the Vishnu schist. And in the Grand Canyon, as it's crushing, it buckles a little bit. So now you got slanted layers on top of the buckled Vishnu schist, but there's still some stuff that's sliding horizontally. So that's how you get flat layers on top of slanted layers in the Grand Canyon. And some of this stuff was sliding. The sandstone, I believe, turns into quartzite, and this chunk of quartzite got lifted up in the mud and got lifted up into a layer of sedimentary rock where it still sits today, and it's, I think, one of the evolutionists' worst nightmares. How are you going to explain that over millions of years? Because it came from the layer down the bottom right, and it's up there, 5 to 10 tons. And there's the coordinates of it, if you ever want to go look. And it's facing north, I believe. All right, so now, how do plateaus form? Remember that double-ended mystery? Well, the mountains rose up, so now you've got a big mass on a small base, and it sinks in. Well, if something sinks in, something's got to move up. So it's the mountains sunk down, the plateaus came up beside it. It's, as it's squishing down, it has to force the magma somewhere. It can't go down, and so it forces it out to the side. The mechanism for breaking, then it block faults at the weak points and goes up. So the mechanism is hydraulic lifting, and the force is gravity. The gravity of the mountains bringing it down squirts out the lava to the sides, and that puts enough pressure on those side ones to break up and go. And they aren't going to all go up at once. They're going to go up one at a time, you know, the weakest ones first. And the lava might get squeezed between the cracks. And the lava gets to the top of the surface. So now you got hard stuff on the sediment, soft sediment, and if a bunch of water comes through with the great denudation, you know, you got to remove 1,000 feet of sediment before you can even think about cutting the Grand Canyon. And that's what happens here. All this water's coming through, and it doesn't take it all because it's covered by lava. And so then you end up with Red Butte, which is 1,000 feet of sediment capped with volcanic rock. So that's how you get, and guess what? It's close to the Grand Canyon. Okay, now I give a whole hour talk on the Grand Canyon, but here are the cliff notes. You know, why did it go through the plateau instead of around it? Bulging and cracking 3 times. Just remember that. We're going to go through 3 bulges and 3 cracks, and it's going to explain Grand Canyon perfectly. But the real force of it all is these 2 huge lakes, Grand Lake and Hopi Lake. They're on the plateau, the Colorado Plateau above the Colorado River. And there's enough water in there for 3 Great Lakes, and they're over a mile above sea level. So that's tremendous potential energy. And then once the Grand Lake starts overflowing its banks, it starts cutting down a V through the softer sediment, and it cuts down until it hits the hard Kaibab limestone. That's why I don't think it was right after the flood. It needed time for the limestone to become rock. And then it spreads out, it makes a funnel, and now there's nothing pushing down on the funnel, so the funnel bulges, that limestone bulges and cracks, and the water goes through the crack, and it undercuts Hopi Lake, which is even higher. And then Hopi Lake starts, now that waterfall, Walt Brown says it's probably 13 times higher than Niagara Falls and 100 times the water flow. And it's just sheet eroding everything on top of the Kaibab limestone. And pretty soon there's nothing pushing down on the Kaibab limestone, so it bulges, making that whole plateau, it bulges, and then it cracks. And then the river runs through the crack and cuts down until it hits the hard basement Vishnu schist, the hard basement rock, and it should get wider because the sedimentary rock is softer than the hard crystalline rock below, but it doesn't because there's nothing pushing down on the basement rock, so that bulges and cracks. And then the river runs through the crack. That's the inner gorge. And so 3 times bulging and cracking, you can explain Grand Canyon. And they've got 4 theories on their park website, and none of them work. So I submitted this one, but they didn't get back to me. So maybe you guys can submit it. And so Walt Brown, what he does, he's got these decision tables at the end of every chapter in this book. And it's just great, because that's how they do it in the military. You know, if something goes wrong, well, what could have gone wrong? There's like 10 or 100 things that could go wrong. And so they make this, okay, for this, there's probably 9 theories for the Grand Canyon, and there's probably 24 features for it. So the theories are on top, the features are on the sign, and then it's red, green, yellow, and red. If it explains it really well, it gets a green light. If it's really poorly, can't explain it all, it gets a red. And if it's kind of, sort of, but a little weak, it gets a yellow. And you'll notice that Grand Canyon is green, or the hydroplate is green all the way down. And everybody else is red or yellow all the way down. And my brother-in-law was taking a class at St. Cloud State, and they were trying to figure, it was a geology class, and they were trying to figure out how Grand Canyon formed. And they spent a week on it. And they didn't have a theory that worked. And then on Friday, the professor said, there's a theory that we haven't talked about. Anybody know what it is? Kid raises his hand and said, no, it's flood. And the professor said, you're right, but we can't talk about it. Even though they'd have a theory that doesn't work, they won't look at a theory that could explain it. Okay, the mid-Atlantic ridge rises up. Okay, so again, if something rises up, something's got to go down. Remember, the mountains went down, so something had to go up. Well, conversely, if something rises up, something has to go in. The mid-oceanic ridge rises up, so what goes down? The Pacific Ocean. It gets sucked in, and that's where you get the Ring of Fire. And that's why all those volcanoes and trenches are in the Pacific Ocean, got sucked down, and all those volcanoes are there. And then also a whole continent got sunk down. Anybody ever heard of the 8th continent? Zealandia? And the 8th continent reveals its buried treasures, and it says that they found evidence of land-based fossils. So that was above the water at one time, and then it got sucked down. It's about the size of India, and all that you see now is New Zealand. Okay, and Walt Brown had predicted you're going to find granite in the Pacific Ocean. And there's granite in the Pacific Ocean. And then he's got that decision table again, comparing the hydroplate theory with the plate tectonics theory. Remember, plate tectonics, that's a godless theory. It's a secular theory. And the hydroplate theory is the Bible one. And it's green all the way down almost for the hydroplate, and it's red all the way down almost for the plate tectonics theory. Okay, and so then how do you get the submarine canyons? Well, all the water that was covering all the continents gush off the continents to fill in the Pacific Ocean and cuts the canyons in the continental shelves, and then the continents sink down and the oceans rise up and bury those canyons in water. So how did that happen on Greenland? Again, the water gushed off, cut the canyon, and then the ice age filled it up. Well, then how do you get the ice age? They can't figure it out according to nature. Well, to get an ice age, you need warm oceans and cold continents. You need warm oceans so you get a lot of precipitation, but you need cold continents so it's snow. And then you also need it to snow more than it melts year after year after year after year. Okay, so how do you get that? Warm oceans, well, all those volcanoes in the bottom of the Pacific, that's going to warm things up. Well, how do you get cold continents? Well, there's, the continents are higher, therefore colder. And also, you got those volcanoes going off, a lot more aerosols in the atmosphere. And that's going to keep the sun's heat from getting to the continents to warm them up. So 400 or 500 years of that, you got the ice age. And during that time, the volcanoes are slowing down and the ocean's cooling off, and then the atmosphere is clearing up, so there's more heat getting to the continents. And so 400 or 500 years to build up, and maybe 100 or 200 years, maybe 300 years for it to melt. And we're still melting today. Okay, and so how come you didn't have glaciers in Alaska? Well, it's because it came down as rain. It was close enough to the ocean, and maybe it was lower altitude, and Siberia came down as rain instead of snow, so it didn't get a glacier there. And then Lake Vostok, these lakes under 2 miles of ice, the same thing there. You know, after the flood, every depression on Earth had water in it, and there were some depressions there in Antarctica, and so now the ice age comes, and now there's a race. Is it going to freeze the water to the bottom, or is there going to be enough snow on top to insulate it? Well, the snow won. Oh, and by the way, they found 91 new volcanoes beneath Antarctica's ice. So if they're freaking out over the glaciers melting, maybe it's those volcanoes. Maybe it's the sunspots. And I encourage people to watch our speaker last month we had at the Twin Cities Creation Science Association, Helmut Welke. Go into our YouTube channel, TCCSA. And at the 4720 mark, he talks about climate change. And he talks about the fraud that's happening there. And he makes some really bold statements like a war on carbon dioxide is a war against life. We need carbon dioxide for the plants. If we had more carbon dioxide, we'd have more food and we'd have less droughts. So again, we need to see both sides of the issue if we want to think. And a lot of times, we only see one side. And yeah. Okay, and so then what froze the mammoths? Okay, these temperate animals. How come they got so cold so fast that they froze one alive? How did that happen? That's the cold hail. Okay, the fountains of the Great Deep were going up with such tremendous force that it escaped our atmosphere and got super cold. And it got in the heat sink of outer space. It's really cold, and what's going up there? Water and ice and mud and rocks and carbon dioxide frozen is dry ice. And then the gravity grabs it and pulls it back down and buries those mammoths. Flash freezes them in a temperate environment. So then you can still see their identifiable food in the stomach. And then it buries them under the ground in that frozen mud and hail. And then Noah's flood comes over it, and then the flood comes off. And Walt Brown, he's got that decision tree again. You know, which theory explains it the best? Again, the hydroplate theory, way to the left, mainly green, and everybody else, mainly red and yellow. And you can go through and analyze it yourself. And then, okay, so that's how it froze them in a temperate environment. But how come they didn't thaw out? That brings us to the big roll. See, the mountains on the northern hemisphere and the southern hemisphere pretty much cancel out, except for the Himalayas. Whoops, except for the Himalayas. There's a red mark there's a red weight on that bowling ball. And so it was spinning at the top, and if there's a big mass, a big weight on the spinning object, it's going to try and get to the side. And therefore something it was on top, it goes to the side, therefore something on the side goes to the top. Therefore, Mammothville, temperate environment, where there's a lot of food and water, they're getting all fat and sassy. The big roll comes and moves them up to Mammoth Chill, where they never thaw out. They're in the permafrost, and we find them in the spring as the rivers erode. Okay, and so if that happened, wouldn't it leave a mark on the earth? Oh, and by the way, that's how tropical palm tree got moved down to Antarctica, and that's how you get the palm trees down there. It was on the side, but then as the earth rolled, it went to the bottom. And that's also how you get the snakes, tortoises, alligators, badgers, and shrews in the Arctic Circle. They didn't live there. That's just where they ended up after it rolled. And if it did happen, wouldn't it leave a mark on the earth? And the answer is yeah, it did. The earth isn't round. There's a bulge at the equator. And as the earth rolled through that bulge, it cracked it. 3,100 miles. And so my guess is the Himalayas were formed 3,100 miles farther north, and something in the Arctic right now is 3,100 miles south at one time. Just my guess. And there you see it, perfectly straight, pointed directly at the Himalayas, just like the theory would explain. Okay, and how come the Petrified Forest National Monument? Notice that's in the bottom of Hopi Lake. Okay, a lot of those in that grand circle, you got Zion and Bryce and Canyonlands and Monument Valley, all those weird features around that area. But Petrified Forest, Walt Brown says that lake had a lot of silica in it. And the silica, it precipitates out of the solution when it cools off, so it had to go somewhere, so it goes into the logs and petrifies it. And you apparently can do that in a lab in a matter of rapidly. Okay, and then Monument Valley, again, that's in the bottom of Grand Lake. And I'm not sure how deep it is there, but Grand Junction, Colorado, that would have been under 1,000 feet of water. And so that's a big lake. And what you don't see, if you were to dig down under all those mesas, buttes, and spires, you'd find 1,400 feet of sandstone, which means there was 1,400 feet of sand at one time when that was a lake. And as the lake drained, there wasn't any pressure keeping it into the sand, so it came to the surface. And as it came to the surface, it would erode stuff, and if there was something hard on top, it would just erode out the side. So that's how you get the mesas, buttes, and spires. That's the bottom of a lake that drained. And then what caused the inland seas? We're going to answer a lot of questions with one concept. What got the chondrules in the meteorites? Remember, high impact, rapid cooling. And how do you fuse past iron? And you could learn all that on Brian Nichols' Origin of Earth's Radioactivity. The Brian Nichols channel is one of the best if you want to understand a hydroplate. A lot of these graphics are his. He spends a lot of time making the graphics and a lot of time writing it out. He's an incredible writer. Just all this information, very logical and very, very, very well done. So I'm getting this information from him. Well, quartz, like I said, is made of 4 different things, and one of them is, this is granite, made of 4 different things. And again, the Earth's never been molten. I don't know if I mentioned this already, but it's made of feldspar, mica, and hornblende. They all got different specific densities, so if it was molten, they'd separate out into their densities. So granite's never been molten, therefore the Earth has never been molten, like the evolutionists say. But anyway, okay, so now quartz is very special. If you squish it or rip it apart, it's going to spark. They call it piezoelectric. Piezo pressure, and then electric is the spark. And so if you put it in tension, that's ripping it apart, it's going to spark. If you push it together, it's going to spark also, compression. And as those the hydroplates, as they're banging up and down, they're going to be buckling like this. So at the top of a buckle, it's going to be getting stretched and spark, and at the bottom, it's going to be getting compressed and spark. And they call all this fluttering. It's going to be going back and forth. And when right there, there's a lot of pressure building up at the end. Then once it gets enough pressure, it's going to shoot up, and it's going to release the pressure, and then it's going to slam down. So it's going to keep on buckling and pressure like that. And so how do those chondrules form? Remember, they need high velocity collisions, and they need to quickly cool. Okay, well, there's a high impact velocity collision right there when those 60 miles of granite come slamming down. That's a big collision, and it could Z-pinch or melt certain areas of the rock, and then it's going to get pushed to the side, and then it's going to get shot up into space and cool quickly. That's how you get the chondrules in space. Okay, how do you fuse past iron? See, on the supernova capability, it can get up to iron, that's not a problem, but then there's some problems with the Coulomb force or the strong force. You can listen to Brian Nichols to get that one straight. But they have this thing called Z-pinching, which can make all these different elements. They take a pure electrode material, it can be copper, silver, or one of 22 materials, and then hit it with a real hot dot. And I'm not smart enough to know how they did that, but what the result is 94 elements and super heavy elements, and it's the same ratio of elements as we find on Earth. But a lot of these are unstable. So they're going to be 2 proton heavy or 2 neutron heavy, and so they're going to decay into this valley of stability. Okay, and it has to do with plasma. When those sparks in the granite, it's like lightning. When lightning happens, there's a charge in the cloud and there's a charge on Earth, and when it gets big enough, there's going to be a spark that goes from one place to the other, and that's going to shear off the electrons, and that's going to make the plasma. And that's what's going to happen inside the granite. There's going to be plasma forming inside the granite, and in the thunderstorm, you hear the kaboom, it just resonates through there. But it doesn't really do that with granite so much, but there is a rebounding effect, and it just smashes all those atoms back together, making the heavier elements that decay into the valley of stability. Okay, and then some people say, well, there's not lightning in granite. Well, they must not have read the Smithsonian. Why do lights sometimes appear during an earthquake? Or mysterious flashing earthquake lights may be explained, or what causes eerie earthquake lights? So it does happen. And this theory explains it. And in the 9th edition, they've got a whole chapter on this. And Walt says you should be able to predict earthquakes based on disturbances in the ionosphere. He says that. But we need to get that 9th edition out there quick. But here's it says, how do you get Earth's radioactivity? And they compare the hydroplate theory with chemical evolution. And the hydroplate on the left is green all the way down, and chemical evolution is red almost all the way down. Okay, and so what caused the inland seas? As all these sparks and neutrons are going on and radioactivity, you might get some weak spots in the crust. And the crust is going to just explode there. And that's how you get the inland seas. It's just going to get a little weak and boom, and therefore the inland seas. And then you get these salt domes. As the water gushed off the Mississippi into the Gulf of Mexico, bringing all these sediments, it's going to bury all that salt, and that salt is more buoyant than the freshly laid down sediment, so it's going to go so far. And again, in August, I want to know how that happens. You know, that's my main question. Okay, and then some of the stuff got shot up with such tremendous force that not only did it escape our atmosphere, it escaped our gravitational pull. So now you got rocks and mud and dry ice and water and ice out there like dirty snowballs flying around. What's been described as dirty snowballs in the, what? Comets, absolutely, comets. Walt Brown thinks that comets came from Earth. That's why Kevin Lee he actually accurately predicted that. And that's why you find stuff like water, salt, silicates, limestone, cubonite, all those things in a comet. Okay, and that's how cubonite, remember, formed in scalding hot water. Well, that's going to be the fountains of the Great Deep. The subterranean water chamber is super hot, and then it's going to just go up there and it's going to be rounded. And that's how the sea plankton got out into the outer space. It got shot up there when the fountains of the Great Deep erupted. And the comet close-up reveals a world of surprises. Remember those goosebumps and dinosaur eggs, the fast flow of water gets shot up there. And this one says there's a diversity of gases coming out of that comet. It's emitting mostly water in one part of it, which makes sense from the hydroplate. In other parts, its emissions are dominated by carbon dioxide, which makes sense from the hydroplate theory. No problem at all. And then they found organic molecules. And now they're going to say, see, the asteroids brought life to Earth. And it's like, no, Earth shot the life into outer space. And if you want to hear Kevin Lee talk about this, go into Rumble, the hydroplate conference, or YouTube or hydroplate.com, and listen to the Comet talk. When I was promoting this at St. Cloud State, I'd tell the professor, I went to the science department telling her it was coming. I went into the president's office, invited her to tune in. And whenever I talked to somebody, and I'd say, if you can only listen to one of the talks, listen to the Comet talk. That's the one. Even before the Air Force professor, listen to the Comet talk. And listen, you go on the one on Rumble, listen at 22:15, where you're going to listen to Kevin Lee standing face to face with the NASA scientist in charge of the Stardust mission. He's going to get stuff from the comet back to Earth. And to paraphrase, Kevin Lee says, you're going to find stuff from the Earth in that comet. And the NASA professor says, no, we're going to find stuff from the Oort cloud in that comet. And they found stuff, from Earth. And so he was shocked. And then in 2016, and you can listen to this at 31:45 of that video, he emailed the same professor. And he said, if you try to redirect an asteroid, it'll work if it's a solid rock. But if it's just a bunch of boulders, it's going to fail. And guess what? It failed. There's 30-some boulders coming at us. So this hydroplate theory is very important. They're making catastrophic blunders because they're ignoring it. And you can listen to that. Also listen to it on Real Science Radio on YouTube or rsr.org on the radio. And Fred Williams, Doug McBurney do a great job. And you can expect, and I was so glad that you can hear it straight from him because he's got it all documented. And so he's been right, makes those accurate predictions. Nobody else was predicting they'd find stuff from the Earth in those comets. And then when he said they presented it, there were 600 scientists who their mouths dropped to the ground. It's like, how did that happen? But the hydroplate, no problem. And so this is the decision table for the origin of comets. And again, the hydroplate theory on the left is green almost all the way down, and there's some that are pretty green too. So it's something to look at. And how do asteroids get moons, and how do you get peanut-shaped asteroids? And how come they don't blow each other to pieces? And this one just came together just gently. It's just kissing it. How do you do that? Well, just the next time you play pool, just observe. Do those rocks or do those pool balls stick together, or do they go apart? Well, that's what's going to happen in outer space too. They're going to break apart. Just look at the rings of Saturn. They're not turning into moons. Look at the asteroid belt. They're not turning into planets. The way you get a moon and a peanut-shaped asteroid is if they're coming from the same spot at the same velocity and they come slowly together, and then they can get a moon. And this is a peanut-shaped asteroid, 624 Hector, has a moon. It's a contact binary, a peanut shape, plus it has a moon. They can't explain either one of them. But the hydroplate, it's not a big deal. We can answer that mystery. Okay, so now how come most of the comets go in the direction of the Earth? So just think the Earth is a train going 100 miles an hour, and you shoot something off at 50 miles an hour. It doesn't matter which way you shoot it, it's going to keep going in the same direction as the Earth. Now let's say you shoot it out at 150 miles an hour. Now there's going to become, if you're shooting it backwards, it's going to keep going that direction. But now let's say you shoot it out at 500 miles an hour. It doesn't matter which way you shoot it, it's going that way. And that's how you can explain the weird orbit that puzzles the scientists, according to space.com. That chunk of ice orbiting the sun in the wrong direction, based on their blind chance perspective of the universe, it's the wrong direction, but not the accurate perspective of the universe with the creator and the hydroplate. It's perfectly fine, no problem. And it says, the orbit of Nico is unusual that it's nearly perpendicular to the plane of the solar system. More than that, it's orbiting in the opposite direction of most solar system bodies. Furthermore, there are a few bodies that share the same orbital plane, with some orbiting prograde, that's with the Earth, and retrograde against the Earth. Okay, that was unexpected. Yeah, when your perspective of the past is wrong, it's unexpected. But if your perspective of the past is right, it's not a big deal. And that's what the professor from the U.S. Air Force Academy did the talk on at the Hydroplate Conference, Trans-Neptune Objects. And he gets published in secular journals. And he says, hey, the math shows that the comets came from the inner solar system. And he was right. This theory is just knocking it out of the park. And you got this decision table again for the origin of trans-Neptune objects. And the hydroplate is green almost all the way down. And the evolution of the solar system is red almost all the way down. So there's a lot of things that are pointing strongly to the creation model, okay, to the hydroplate model. Well, wouldn't it leave a mark on the moon if that happened? All that stuff shooting out? Well, yeah, it did. That's why there's low density on the far side and high density on the near side. You got all these the lava flows on the near side, and the far side doesn't. They call them mass cons. How come you got mass cons on the near side, high density things there? And then that's how you got the moon. The oldest Earth rock is on the moon, made in a water-rich environment. Oh yeah, that makes sense. Crystallized and down there, and then the moon is rusting. Yeah, that's because there was oxygen on the Earth that went up there with the rocks. And very puzzling. And then this is what I really like. Creation.com did this article called Flood. And they described all these flood models from around the world. And Scandinavia's one is fascinating. It describes the hydroplate perfectly. He says, the axis on the Earth was shaken from its roots to the topmost branches. Mountains crumbled or split from top to bottom. Men were driven from their hearths, and the human race was swept from the surface of the Earth. The Earth itself was beginning to lose its shape. Already the stars were coming adrift in the sky and falling into the gaping void. Flames spurted among fissures. That's the lightning in the granite and in the rocks. Spurted in fissures in the rock. Everywhere there was hissing of steam. That's the supercritical water coming up. All living things, all plant life were blotted out. And now all the rivers, all the seas rose and overflowed from every side. Waves lashed against waves. They swelled and boiled and slowly covered all things. The earth sank beneath the seas. Then slowly the earth emerged from the waters. Mountains rose anew. I think that describes the hydroplate perfectly. Okay, and again, I'm not impressed with Walt because he's got letters behind his name. I'm impressed because he makes accurate predictions. And here's some of his accurate predictions. He predicted that beneath major mountains are large volumes of pooled salt water, confirmed. The crystalline rock under Gibraltar and other places would be V-shaped, confirmed. And their soil and erosion channels on Mars will contain trace amounts of Earth-like soluble components, confirmed. Some comets, asteroids, and meteors will be found to be made of crystalline material and forged in extreme heat, confirmed, like cubonite. And some large and near parabolic comets, as they fall towards the Earth, or the solar system for the first time, will have moons, confirmed. And that's a hard one. A hard one for those secularists. Asteroids are rock piles, confirmed. And then most rocks and pebbles will be rounded, confirmed. And then also Planet X will not be found in the next 5 years by January 2021 because it does not exist. So he's making very specific predictions that can happen in your lifetime. And then bones and other organic remains will contain carbon-14, confirmed. And we find there's, because what did she say? That person, the professor said, I don't believe there's water under the oceans. that she didn't believe the assumption. And I said, why not? There's water under the ocean today. You got these black smokers coming up at 800 some degrees. And Job talked about the springs of the sea. And we didn't find out about them until 1977. So the Bible's always right when it talks about science. And this is one of the footnotes from the 9th edition. And I tell you what, just do some surfing from idea to idea. It is so fun. And it says, down at the bottom of the Atlantic Ocean is the hottest water on Earth in a supercritical state never seen before. And Walt Brown goes on to say how that couldn't happen without this theory. And this says, oh yeah, and also supercritical is seen jetting up from the floor of the Gulf of Mexico. I just threw that in there so you guys might see it someday, I don't know. Okay, so we have all these unanswered questions, all these, they're always surprised, all these mysteries. And yet with one theory, we answer them all. If you don't want to be confused, look at the hydroplate theory. And I'm going to kind of start winding down. Widespread belief systems seldom change when frequently reinforced by influential institutions such as universities, medias, and even creation institutions, and the scientific and intellectual elite. But when vast numbers of people realize they have been misled, an intellectual revolution begins. Okay, and that's my goal. I'm trying to reach a vast number of people and say, we've been misled from our government institutions. We've been misled. And so then we can have a scientific revolution. And observers of the revolution should note which side avoids a rational scientific debate. And that'd be the evolutionists. It's hard to find them to step up to the microphone. And other ones too, And so, oh yeah, I got this email one time. So I love this here. I love talking about it. It seems like everybody I meet wants to talk about it, so we talk about it. And I got this email. It says, my best friend is Joe. And I wanted to reach out and let you know I've been praying for Joe to come to know God for quite a while. I've been praying that God would send Christian men into his life and have real conversations with him. Specifically, I've been praying that God would send intelligent Christian clients who would talk to him. Brian, you are an answer to prayer. Your conversation with Joe has opened his mind. I believe he's been watching your videos a bit because he shared one with me. And I emailed her back and said, thank you so much for the encouraging words, but I'm really curious. I got over 100 videos out there. Which one did he send to you? And I was shocked when she sent me, this is what he sent to her. A 5-minute, I got to speak to the Rotary Club. I had 20 minutes. So I squeezed an hour talk into 20 minutes. And this was during COVID, so there's no doors on the room, the hotel, or the restaurant room. So there's a lot of background noise. So I tried to edit it out and it doesn't work. So it's rather poor audio. But it made me realize it's not the quality of the audio, it's the content of the audio. And so this is again, the hydroplate theory. And Walt Brown goes on to say, question everything yourself, starting with this book. Question everything, and I mean everything. See both sides of the issue before you believe anything. And you can get this book for $50 right over there, and also you can get it online for free. Go into rsr.org/HPT. You're going to see the cover of this book. Go right underneath the cover. It's going to say 9th edition. And you can download that for free, and you should, because the internet could be taken down at the drop of the hat. And then also on that same site, you can listen to Walt Brown Week. That's what covered in the details for me. And also, let's see, what else? The Walt Brown controversy. You might be thinking, man, this is a great theory. How come I haven't heard about it? Well, there's a reason you haven't heard about it. You can listen to Jane Albright. She critiques all the flood models, and she talks about why you haven't heard about it. And it's really a sad commentary on Christianity, I believe. Okay, and then this is the hydroplate protocol. Okay, go into rsr.org/answers, and you're going to see all the published criticisms of this theory. And you're going to see the YouTube criticisms of this theory. And then you're going to see how we answer those objections. Okay, so wouldn't it be neat if evolution would do that? Hey, here are the published criticisms of this theory. You can get all this on one website. So you have all the information, so then you can think for itself. And yeah, the hydroplate could be wrong. It could be. I'm not married to it. But I think the framework, it might be wrong in one or two areas, but I think the framework's pretty solid, making all those accurate predictions. And I encourage also people to go onto Brian Nichols' website. This is on YouTube, and also Real Science Radio, and again, the Jane Albright one. So with that, I'm just going to leave that up for now. I got 2 minutes over. You can most switch computers. And let's see. Any questions while we're doing this? Those are oh yes, and again, thank you to Frank for allowing this. I appreciate that. Thank you for Grace Baptist for allowing us to be here. and we just pray that it would be used for God's glory. And I'll just leave this for now. Okay, we'll switch. All right. Okay.
Frank actually saved us some time because his intro didn't take the full 15 minutes. So it looks like I got actually 2 minutes. You could have went 2 more minutes and you'd still been on target. So we're in pretty good shape. I'll go ahead and start my timer so I can kind of know when the 30 minutes is out. So in the first part of my discussion here tonight, I would like to consider the biblical foundation for the hydroplate theory. See, I'm a young Earth creationist. To be a young Earth creationist, you have to take the Bible very literal in the early parts of Genesis, where everyone else likes to fudge and compromise. I take it literal, and I try to take it as simple as I can and take that literal, and I make no apology for that. And so when it comes to the hydroplate theory, the one part that I like about it is that it allows me to go into the Bible and take the scripture and stay to a very simple interpretation. And I have a great amount of support then with simple interpretation, and it works. And that makes me favor the hydroplate theory. I mean, there's a lot of science here and there, but let's face it, if the Bible doesn't undergird it, we're just messing around. We're just shooting in the dark. And so with that, we'll go ahead and start. And let's start reading Genesis 7:11. In the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the foundations of the great deep broken up, and the windows of heaven were open, and the rain was upon the earth 40 days and 40 nights. Can you imagine if you were there and you'd never seen rain before? You'd never seen lightning before? And all of a sudden this stuff started happening, and you say, he invited us on that ark, and I chose not to go. But it would be frightening to hear lightning for the first time in your whole life like that. But that's kind of what happened as the flood started. And I think it was more catastrophic than just a thunderstorm, as we will see. And we continue reading in Genesis 7:19. And the waters prevailed exceedingly upon the earth, and all the high hills that were under the whole heaven were covered. 15 cubits upward did the waters prevail, and the mountains were covered. And the waters prevailed upon the earth 150 days. It's hard to tread water for 150 days. You wanted to be on the ark of safety, didn't you? So I would like to focus now a bit on this phrase that we find in Genesis 7:11, the fountains of the great deep. So we're going to take a little time to dig in, because this is one of the big clues as to what model you should probably try to take when it comes to a flood. And so we're going to study this phrase. What does the phrase mean? Why does it precede the rain? Is it possibly related to the rain? And if so, how is it related? So we're going to try to touch on all of these as we go through. When you say the word fountain, what comes to mind, and especially when you look at natural earth fountains? Well, we have cold water geysers in Germany, and they're actually powered. They're cold water. They're powered by what? Well, they're powered by CO2 gas. And how is that? Well, it's like taking a Coke bottle and shaking it up with your thumb, and then take your thumb off of it, and guess what? It can rise liquid to a new height by the stored energy that is in that CO2 gas. We have hot water geysers that are natural on Earth. We have this one here in Iceland. And what's it powered by? How does it raise its water to so much of a height? Well, you have H2O gas, water, gas, steam. And how did it get to be steam? Well, somewhere below there are heating elements that are heating that. And we know when you take a coffee pot and you put water in it and you heat it, you can actually raise you can raise the water to a new height just based on the heat content of the water that you pumped into it. Well, then what powers, say, an oil gusher? That's also a natural fountain of oil. Well, it's the strata weight on top of a pool of oil. So if you look at the bottom of that strata, you see that little black patch? That's a reservoir of oil. But guess what's sitting on top of it? All of that rock. You think that rock is weightless? If you swim to the bottom of the pool, you feel a lot of pressure. And if you swim to the bottom and get yourself in that water, that pool of oil with all that rock on top, it's extreme pressure. So then when you drill from the top down, see that? I'm drilling down and then I hit it. Guess what comes up? And makes a fountain. And it shoots up into the air by the weight of gravity. The potential energy of gravity itself is what raises that up and shoots it. Now, we've got one here, the spindle-top gusher. It's a very famous historical gusher. It rose 150 feet into the air. So what powered it? It was the gravitational weight of all that strata on top that pressurized it, and then we had a channel that went down and it escaped. Let's look at that spindle top. January 10th, 1901. The world had never seen a gusher like this. And it rose 150 feet into the air. Up from the ground came a bubbling crude oil, that is black gold, Texas tea, the hillbilly song. The world not seen this. This was new. No one knew you would get this kind of a reaction by drilling down there. And, 100,000 barrels a day were spewing out of control. They didn't have a spigot to just turn it off. You talk about panic, but look what happened. Of course, that's 4,200,000 gallons. It blew for 9 days. It's the largest gusher the world had seen. It set a record beyond everything. Beaumont's population of 10,000 tripled in 3 months after that. I told you it was black gold. Oh, you can go get some gold, black gold. People started pouring into that area. By December 1902, more than 500 companies had formed and 285 wells were in operation. Black gold, Texas tea. That's why. And the worst was yet to come. About 29 years later, now we're at a depth of 6,741 feet. And Wild Mary, they call this one, Wild Mary. It spewed oil up 400 feet into the air. That's a lot more than 150, isn't it? Okay. The gusher vented 200 million cubic feet of gas and up to 75,000 barrels of oil a day. Now, what happened is the Roughnecks were drilling, and they needed to change the bit. So they thought, let's pull all the pipe out with the bit and then change the bit. What they didn't know is the bit had done its job. It actually had gone all the way down, and it pierced through and into the oil-bearing strata, and just before they started to pull it out. It's called the Wilcox sand. It had pierced through it. They didn't know it. Oh, we'll just take the pipe out. Well, they started to take the pipe out, and guess what that did? That left a hole for it to come up. They said the pipe started rattling. So you're trying to take the pipe up. Normally that's smooth operation. It started rattling and rattling. The pipe is rattling. And all of a sudden the pipe shot up in the air like toothpicks. The sound was heard 30 miles away in Purcell. And it permanently deafened some of the workers on the rig that were working there. They never regained their hearing. That's how loud it was. Well, I would like to focus on the word fountain and say, if you say the word fountain, what do you think? What comes to your mind? And first I'm going to talk about man-made fountains, because we make fountains, don't we? And we use them. In fact, I use that one in the back of in the lobby there. And that's called a drinking fountain. That's man-made. It has some pressurized water, and you push the thing, and it goes up in the air, makes a fountain, and comes back down because of gravity. We have man-made fountains sometimes in a pool, in front of a hotel, or maybe casinos or things like that. But I think the most spectacular man-made fountain in the entire world is found in Switzerland. And they have pumps that can pump 130 gallons a second with great horsepower, to the point when it comes out of the pipe at the level of the water down below, that water column is moving 125 miles an hour. And it shoots up in the air 450 feet. That's a man-made fountain. It's pretty spectacular. So those are man-made fountains. But you know what? We can look at natural fountains that are then managed by man. So we didn't make the fountain, and they're horizontal fountains, but then we come behind it and say, oh, look at that, and we manage it by then shaping it and taking control of it. And so I wanted to show you this one. It's the natural fountain of Tinaja de Vargas, Michoacan, Mexico. And when you get into this little, I would not hardly call it a town, I'd call it a village. It's out in the absolute middle of nowhere. You cannot get here very easy. And you are going down dirt roads that are not marked, and sometimes you have to stop and go back and say, I guess it's this way because it's not the other way. I know, I made this trip. I took these pictures. You go down that little village road till you hit the base of that hill, and it abruptly then turns and goes right straight up the hill. I mean, it's a steep cobblestone street that you're climbing to get up that hill. You go about halfway up the hill, then it stops, then it levels out on top. And here's what you find when you get up there. You find water coming horizontally right out of the hill. Now they have taken and put concrete over the top to protect it. They've jammed a metal pipe down that thing to kind of make it go through the metal pipe, and then sealed it off with concrete. But you see that stream, that horizontal stream of water, and then it comes out and it drops and makes a reservoir, and it drains over to that big trough. And that trough is where the kids swim, where the women wash their clothes. And when we were there for a while, the kids were in there and splashing, and I'm telling you, they had water everywhere. This is the natural fountain of Tinaja de Vargas. And that little town exists because of that. Now, it's not ancient. The town's about 150 years old. But the villagers and the history of that go back 150. They said, in even drought times, that water has never failed. That water continued for 150 years to feed our little town. You say, wow, how did you go to find such a little bitty thing? We see on June 1st, 1891, my grandfather was born there. And I wanted to go see if maybe some of his relatives still lived there. I was doing genealogy work, and it took me 7 years just to track where he was, and I finally figured out. They said he's born in Tinaja de Vargas, Michoacan. So I went there, and they told me there's an amazing water that comes right out of the mountain, horizontal, and it fed the town. And then it runs on down, and they do the crops. Interesting enough, that water's pure. Now, when you're in Mexico and you're not used to the water, you got to be a little careful, even if you're in the big city like Mexico City or anywhere else. If you're not used to their water, there's little things in it that you might have to adjust to. They've called it Mexican two-step for a good reason, because you won't get to the third step. Anyway, this is my nephew drinking water. We got there. We were told that when you get there, you can drink right out of it. Nobody gets sick on this water. Pure. It's a fountain coming right out of the mountain. There are ancient fountains that man have managed. This one here in Rome is more than 1,000 years old that we know. And again, they have built concrete things around it to dress it up, but they put a little artwork to it. And so here's an ancient fountain in Rome that dates way back. But the most ancient of all of the fountains on planet Earth that I know of, that I could find, is the one in Israel. And it dates back to 1,445 BC. And you say, wow, how do people know precisely that date? Well, it's in the Bible. You remember Joshua? He finally came across, and they had their 7-year war, and then they were going to part the land, and this fountain of Neptoah was going to be one of the markers between Judah and Benjamin. But we can think, okay, that's what we think of when we say fountains, but what does the Bible say? I don't care what people think or even I think. What does the Bible say about fountains? So what I did is I took and did a search. And this search is fountain singular and water singular. And I said, show me every scripture that's got those two connected. And so I have 10 results here. The red line, below the red line, is the New Testament. James through Revelation. The other's the Old Testament. So we have 10 results where the fountain and water are both singular, and we have that connection. Then I did a search with fountains singular and waters plural. And I said, okay, what do we got there? And we got 7 more. And the red line, there are no New Testaments with that combination. Then I did one with fountains plural, but water singular. And guess what? I got 6 more hits. Then I did one with fountains plural and waters plural in the same verse. And it came back with 6 more. Some in the Old Testament, and all the rest were Revelation. So when I summed up all of that and gave you a nice summary, there were 29 scriptures. And it didn't matter how you cut it or diced it, singular, plural, both, mix it up. In every case, water and fountains in Scripture are tied together. I told you I like things simple. This is the kind of simplicity that you see. So fountain is correlated to water. Now you can do a search with fountain, and in your search engine put in brimstone. Do fountains and brimstone connected? You know how many I found? I won't mention it. I didn't find any. Anyway, you can go back and then study the Bible and this fountains of the great deep in the Hebrew, and you can look at the way the Hebrew structure of the language is. And in this case, when you look at it, it's all from the fountains, deep, great. You say, well, they kind of talk funny. Well, we turn it around a little bit in English, but that's how we get our translation in English. All from the fountains, deep and great. So let's continue our Bible study here. There are Old Testament scholars that know Hebrew very, very well. One here is Gerhard F. Hassel, Associate Professor of Old Testament and Biblical Theology at Andrews University. And he wrote a paper, and in the introduction to the paper, it says this: the phrase "fountains of the great deep," as used in Genesis flood account, is both intriguing and significant. The author presents an analysis which gives insights into the original meaning of the expression. And then he takes off, and it's an hour to an hour and a half of detailed Hebrew this and that and word structures, and I thought, well, I think I'll have to share that with you guys. Then I thought, no, have mercy on them. They would fall asleep, I think, halfway through it. I will just jump to the conclusion. No, don't thank me. So let's look at the conclusion of Mr. Hassel from Andrews University. Here's what he said after doing all that study. He said, in short, on the basis of comparative philology, and the Hebrew terminology as used in Genesis 7:11 and 8:2, as well as consideration of the literary structure of 7:11, it appears that the bursting forth of the waters from the fountains of the great deep refers to the splitting open of springs of subterranean waters with such might and force that together with the torrential downpouring of water stored in the atmospheric heavens, a worldwide flood comes about. He said you cannot escape the conclusion that is definitely talking about subterranean water reservoir down there somewhere that started the flood. So that was his conclusion. You can take a regular Logos Bible software. This is an older version. It's kind of a dumbed down version where I can even follow it. So we did some searches there on the word fountains. And first thing I would know in Genesis 7:11, it's not fountain, it's fountains, plural. So down there was not one, but a bunch of them. And it says all of them. Not, in other words, one of them didn't accidentally rupture and come up. All of them did. And guess what? They were deep. No, they were not deep. They were great deep, the Bible says. And they were broken up. And the windows of heaven, which is mentioned after that, were opened. And amazingly, all of that happened on the same day. It was catastrophic. You can do a search where you can show what the strong number is. Like for fountains, you have the strong number 4599, which is Mayan. And you can find it also in Joshua 15:7, the same one, the fountain, Mayan. Then you have the word water, which is 4325. And then you can click on that and do the Strongs on it. That is Mayim, and it means water or waters, depending on how it's used. Then there's the strong number 5318, Neptoa. And it means opening. Opening. So now you put all of those together. Mayan, Mayim, Neptoa. That's the Hebrew. Fountain of water at the opening. You see, folks, there was an opening. And you really wouldn't want to be standing on that opening when it happened. Let me just tell you that, as we will see as we go on through this. Now, Neptoa is today been changed the name by the Palestinian villagers to Lifta. That's what they call it. But archaeologists have gone down and dug around the foundations of that reservoir, and they say what's under there is really, really ancient. It sure is. It was there in Joshua's day. So here's another one, Hebrew Torah, Foundations of the Great Deep. Creation Wiki is made available by the Northwest Creation Network, and their title here was Springs of the Great Deep. And here's what they say. Springs of the Great Deep, or the fountains of the Great Deep, as in the King James Version, are described in the Bible. The Bible gives us an example of what Mayan means in directing us to Neptoa. And the border was drawn from the top of the hill unto the fountain of the waters of Neptoa. At ancient Neptoa, now a ruin called Lifta, just northwest of Jerusalem, is a spring whose waters are collected in a great walled reservoir of very early origin. This reservoir makes the fountain of Neptoa unique among all other wells and springs and cisterns of the Bible. Joshua 15:9. Here's their concluding remark of that study. In light of this physical evidence, Joshua 15:9 may better be read, and the border was drawn from the top of the hill under the reservoir of the waters of Neptoah. And similar substitution into Genesis 7:11, having learned all of that, now put that same logic into Genesis 7:11. It would say, the same day were all the reservoirs of the great deep broken up. On that day, all the reservoirs of the great deep burst open in the NIV. So there's the conclusion. Now, the town called Lifta is there today. You can go visit it if you go through Israel. And it dates back to Joshua chapter 15:9, Joshua 18:15. It's actually mentioned. And archaeologists have identified it clearly when they traced out what the border between Judah and Benjamin was. They could see that is a landmark. Now, in the Bible, Joshua did not give that water to Judah and put it on the Judah side. But he didn't put it on the Benjamin side. He put it right on the border so they'd have to share the water resource, because water resources are rare. And then they built rocks around it. They dug pits, diverted the water for a while till they could get the pits dug, plastered it, let it dry, diverted the water back, and began to fill up a reservoir. And that reservoir and that water has not failed since 1445 BC to this day. It continues to bring fresh water. Isn't that amazing? So let's look at the map. So here's the border between Benjamin and Judah, and that little flashing dot up there is the fountain of Neptoah, or the reservoir of Neptoah. And here's a picture of that area and the hillside. Remember in Tinaca de Vargas, it came halfway up the hill and it just come out, and they had to manage it. And here you go partway up the hill, and I will make it easier to see. The fountain reservoir, there it is, dating back to 1445. And right there, that little spot, that's where the water comes right out. Now, you can't see the dirt because it's further back. They've put rocks and all kinds of structures there to protect it and to channel that water. But there it is. Here's a close-up, and you see that water coming horizontally out, and then a fountain of water coming down and filling up the reservoir. Some tourists go there. It's not well known. I bet nobody in this room's ever heard of that little place. But there are a few tourists, and when they do, read books, put their feet in the water, the kids jump in the water. I'll bet you Joshua's kids did the same thing. So now I'm going to take the fountain reservoir of Neptoah, and I'm going to apply it to the hydroplate flood model. And I'm going to take parts of this picture and to build the reservoirs of the Great Deep. Okay? So let's grab that slab, and then we're going to duplicate it. And that's going to represent 60 miles to the surface of Earth. We got the two reservoirs here that are looking, but as you go around the Earth, there's many reservoirs. Reservoirs plural. And then if you go on down, it's hot. The Earth is hot, and we will see that a little bit later. You can go down 9 miles, and you can't drill no more because it's so hot. The bit won't hold the diamonds in it. So here is a depiction of what the reservoirs of that were occurring there at the time of Noah. Nice and stable, but hot. As Brian was saying, they're dissolving the basalt below and the granite above. And after 1,656 years, it's packed full of minerals. It's ready to go. And then I'm going to put this mic down where you can kind of hear this. Something happened. Now, these are the fountains before being broken up. Now, notice I can draw them. I can show this to a child, and they can go home and draw it for their parents. 60 miles reservoirs. This is what fountains look like before they are broken up. They're not a fountain only after they broke up. The Bible says they were the fountains, then they were broken up. Earthquake started breaking down the pillars. Cracks started toward the surface and finally got to the surface. Boom! And the waters, under pressure, shot up into the air. Then the cracks started moving horizontally. Because granite is very brittle. Once you start a crack with that kind of pressure, it wants to continue on. And so it continued on. Why would it go horizontal crack? Well, we have the longest pipeline brittle fracture in history, ran for 8 miles, destroying more than 1,000 pipe. Now that pipe had a fracture toughness that was greater than 7. In fact, the fracture toughness of granite is a very poor 1.63 square root inches is what they call it. If it's a high number, it tries to stop the crack. If it's a low number, the crack just keeps going. The poor Titanic steel rivets are 7 KSI square root inches. And Titanic sank because of brittle bolts. They snapped, then the next one snapped, and the next one snapped, and it was like a chain reaction. Snap, 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 snap. And guess what? Granite is even just terribly poor compared to all of that. And so once the crack started horizontal, it just zipped around the world. And then what happened to those other cracks? So this is just a model of what it would look like. Now these I can put down, these are the fountains after being broken up. These look more like your drinking fountain where the water comes up and comes back down. But these were coming up with great force. We're going to look at that force. Whoops, I guess I need to speed up a little, don't I? What time is it? Okay. And of course, this is Walt Brown's hydroplate theory. And of course, the height that it goes would be the potential energy of the strata, the weight of the strata, and the heat energy, H2O, of the water being heated. Now, fountains of the Great Deep in the catastrophic plate tectonics, here's a picture of it. And of course, this is the fountains after being broke up. But the question you have to ask is, what is the picture of the fountains before being broke up? I think it's harder to match this than with Scripture once you start looking at what was the fountain before it broke up. Draw it. Now go compare it to Scripture. Can you find Scripture that will back it up? I struggle there, and that's why I kind of favor the hydroplate theory. Russians have dug down as much as 7 miles. They couldn't go anymore. They were going to go 9 miles. The bits would melt, wouldn't hold the diamonds, and this is still the deepest man-made hole of all. So the crack would go, and then here's a kind of a, whoops, I'm sorry, boom, there we go. I think Brian kind of showed this already, but the more it came out, the more it eroded away. I'm going to skip some of this because it's kind of a repeat, only with different graphics. Here's an interesting picture. This little 7-year-old boy with a boat full of people put his foot on the boat in the water, and then he said, "Are you guys ready to go?" And then he pushed it. And a little child can move that much mass with a foot. All these hydroplate models, all that is on top of water, giving it a more frictionless surface than, say, on top of magma or anything else. I'm going to skip some of this because it's a repeat of what Brian has already showed, but there are bulges and the plates would then go apart. So here we see the continents breaking apart as that crack goes all the way around the earth, and then the water coming up has a side pressure on it, and the continents begin then to break up. "15 cubits upward did the waters prevail." We'll finish with the Bernoulli, and then that'll finish it. This is the Bernoulli equation that tells you how high a geyser will go. If you hit oil at a certain pressure down below, how high will it go? This is the equation that tells you. This is used in the oil industry, and it's also used in the nuclear piping industry, where they're taking pipe to maybe 200 feet up and then over, and they can know what the pressure is all over the pipe system. They use this equation. So you can take that equation, you can take this NEPTOA model, 60 miles, apply the equation to it, and you find that the weight of the granite would make 372,000 psi down below. And then when you let that pressure loose, it will go how high? Well, you can solve this equation. Using the equation, you can actually solve and then calculate. And you get H, which is the height from the reservoir all the way up, 162 miles. Then you subtract the 60. That would shoot water, just with the pressure of the strata alone, 102 miles up in the air. And that's significant. You know why? Because the lowest orbit that we can put satellites in orbit at 75. I don't even need any heat to get it in orbital space. Just the Bernoulli equation alone, you're already in space. But then we know it's supercritical water, and that's going to add a huge amount of energy and propulsion to launch it on out from there. Okay? Now you take the same equation and you solve for how fast is it coming out of the ground. And that's a different equation. So now you solve for V vent. It's a square root of that big beast up there. But if you choose the right coordinate system, you can make some of those go to 0. And then the question is what is the vent velocity? With that much pressure down there, shooting it up 60 miles, when it finally got to the surface, accelerating the whole time, how fast do you think it came out of the ground? How fast? Put it in your mind. How fast do you think it came out? Here's how fast. Mach 5.25. 5.25 times the speed of sound. You can imagine those guys on the rig that were deafened by this, go 60 miles below and let that one get away. 5 times the speed of sound. That is a sonic boom, folks. The escape velocity is 33, Mach 33, or 7 miles per second. So it's not Mach 33. The Bernoulli by itself can't get you into escape velocity. So if that's the case, then you have to explain that where the additional energy comes from, and that's the heated supercritical water, which then take you from orbit type heights and then launch you on out and escape velocity. Bull 17, 2,348 BC. If you do the Julian date, that'd be December 2nd. Gregorian date would be November 12th. So November 12th is about the time of year that the first flood started. Heshvan is the... See the little man standing at the bottom? He would be blown away. If you were that close, you would be dead almost instantly with the power of these subterranean waters coming up as like a reservoir. And I'm going to go on. We launch planes with the same thing, with heated water. We can launch a 45,000 pound jet at 165 miles in 2 seconds with water heated. So it has great propulsion. So you add that to it. Things could have escape velocity. Some of it might have hit the moon. Others with escape velocity may have flown out to Mars and beyond, and comets and other things into further reaches of space. Don't be willingly ignorant of the flood. Second Peter says some are. Let's all keep an open mind. Study it hard. This is one of my last slides here. Water reservoir below, the mass of granite sinking as the water comes up. It's depleting the water underneath and building up the water on top. So the reservoir below is transferred to the reservoir above. Just like the reservoir in that Jewish mountain is being depleted and filling up the reservoir of Neptoah. So there's the timeline in thousands of years to today, Jesus, and here's the flood, about 1656 from big creation. If you want to know that kind of in chunks of time, how many years from one event to the other, and the church age another 1,944 since Jesus, total 5,994 from creation approximately, depending on how you slice and dice your Bible chronology. And so with that, I will just go to my last point. Why is it that non-believers do not like the concept of a worldwide flood catastrophe, even though there's overwhelming evidence of it? And that's because it speaks of judgment, and that's scary. The fountains of the great deep were used by God for the destruction of all mankind and animals that were on the earth. Yet, the fountain of water from the flint rock that Moses struck was used for the preservation of the nation of Israel when they wandered 40 years in the desert. And Jesus, it is said, is the living fountain of water, freely given, that can save any man's soul from hell. So it's a two-edged sword, these fountains. Make sure you're on the right side of the fountain, and don't be ignorant of the flood. I'm going to close it right there. I'm going to go on to the last slide. Questions and answers. You want to come and join me up here? I hope my Bible study here would kind of enthuse you to go home and study it for yourself. Don't take my word for it. Okay. Someone want to ask a question, just step up to the mic, and we'll field some questions. You got a question? Are you afraid of the mic? Or were we so good we answered all your questions? If that's the case, we can go home.
My question was about the water being so terribly hot underneath the earth. At what point, I guess, I don't even know how to ask the question, how can we survive that? I mean, what cools it off?
You had a picture of a guy with a pressure cooker. You might just explain it. I don't think we have time to put it up.
Oh, okay.
But you might explain to her what you can do with a pressure cooker of hot steam.
Yes, a gas or liquid expands, it cools off. I think it's the Joule-Thomson effect, and there's a video that I had ready, but I don't have time to show it. But it's this science teacher, and he's got this boiling thing, and it's shooting up the steam, and he's got an oven mitt, and he puts it over there, and he says, "Okay, class, would I dare take this off?" And he takes it off, and he puts his hand there. And he says, as it expands, it cools. And so...
In chemistry, they call it endothermic or exothermic, and the expansion is an endo, so it actually cools back down. And remember, that's right here on planet Earth, with just that far from the pressure cooker. As you go on up past Mount Everest, how cold does it get at Mount Everest peak? Really cold. And now the pressure is really thin, and it expands more and cools even more. And then it goes on into outer space. And now it's in a vacuum, and it really expands, and it cools down even more. Okay? Okay.
Yeah, I think there's a Joule-Thomson effect too. I think Joule-Thomson.
Anyone else want to
Come on
belly up to the mic?
Come on up to the mic. Feel free.
This mic has never bit anyone.
You have to belly up to the mic too.
Huh?
You have to belly up to the mic too.
I just got one, but I think about something about mostly you got caves underneath Earth when you see caves most of the water goes in through caves and makes formations inside the caves underneath of the ground.
Oh, you're talking about like stalactites that are in caves that are under the ocean.
Yes,
They
mostly
can't
they
form,
come on.
right, they can't form if they're under the water, and they probably formed it during the Ice Age. Because when there was all that ice on the continents, the ocean level dropped 125 meters. And so my guess is those caves are less than 125 meters, 325 feet below the surface. And then as the ice melted, it filled, the stalactites formed when the ice was up there, and then the ice melted and raised the ocean level. And I think they even found like cypress forests like 60 feet deep off of Alabama's coast. So there was stuff that was different in the past. And I think they've even found like foundation, civilization buildings like 30 feet below the water off of China or Japan or somewhere like that too.
Like you see other caves, yes, from other areas and countries.
Also, I might mention that if you look at the cave or the reservoirs that fed all this, they couldn't do stalactite because it was dissolving granite. So if it was it would just dissolve. It dissolved the basalt below and the granite above, and was very much saturated with minerals. So as far as those, for sure, there were no stalactites there at that time. Okay?
My view of the flood was a violent event, but it doesn't come near to what the violence that you're describing here. And I'm thinking, how would the ark, apart from being protected by the grace of God, how would the ark survive these tidal forces and these explosive?
Yeah, I would like to answer that. When it comes to the ark, had the ark been right at one of these cracks, it would have destroyed the ark. But the ark didn't even start floating for 40 days. That means as the waters rose, now the waters rose in 150 days to a peak, but it didn't get to the ark and raise the ark till 40 days. See what I mean? So 40 divided by 150 means that it wasn't at the seashore either. If it was the ark had been made at the seashore, it would have started floating on day 3. But it didn't. It took 40 days for that water to get up, and then the ark was not where the vents are. The vents could have been, a half a Earth quadrant away, and so it wasn't hurt. But it also had to sit there and wait 40 days for the water to get it. So it tells you that the ark was about 25% in elevation from the peak upward, so the ark was already at higher elevation, about 25% of the total. And that's why it took 40 days for the water to even get to it. Okay?
Follow-up question. So the tidal forces would not have been as great by the time the floodwaters got to the ark. Is that
Well, yeah.
like the size of waves or such?
Yeah.
Well, I think the waves got even bigger after the ark started floating, because once the continents were buried, there was nothing stopping those tides from just going all around the world.
And the fact that we're here tells you it didn't topple the ark.
Right.
Yeah. The stability of the ark is amazing, and that's also been studied.
Yeah, the same dimensions of the ark are now used in ocean liners because it's
Right.
such a stable.
Yep.
Right.
Yep, and it's the ratio 1-6.
Yeah. It's one of the most stable ratios.
And
Noah didn't know it. God told him.
right. And sometimes people will say we got our ark story from the Babylonians, Gilgamesh. Well, that was a 7-story cube. That's not seaworthy.
Right.
The first shooting up would be very tremendous and high.
Yep.
But I'm thinking that as the fissures opened, that the fountains would not have gone as high due to the release of the pressures. But what do you think?
According to the Bernoulli equations, it would shoot up there even with a small crack. However, if you notice my last slide, one of my last slides, as the water started building up on the earth, now the crack jet of water has to go through the thickness that's building up. And if you take a hose and put it at your swimming pool just a 1/4 inch under, now put your hose on further down, and within 6 to 8 inches, it's barely making anything. But yet, when you put it near the surface, it can go 20 feet. I actually did this with my grandson, and I've got pictures of how, as the water then built up, as the flood advanced, now you've got a layer of water that's choking off the jet, and so now the jets don't go as high. They go lower and lower, and finally they're just making a bulge of water, and they're not even going very high at all. Okay?
Here's that video. There's not.
Oh, that's the one, yes.
So basically the
He's
steam
going to
is,
take that glove off.
and he's saying, you know, as it expands, what's happening to the gas? And he says it starts with it cools off. The gas is doing what? He won't put it right down there.
Very good.
Yes.
Yeah, I want to start with a comment. When you say plate tectonics is a secular theory, it was actually first proposed by a creationist before they had that, but some Italian came up with the idea, but he tied it to Noah's flood, so it was never accepted in the scientific community until someone came up with it later. So plate tectonics is not a secular theory. But I guess my other big question is saying how all that 40 miles of granite could have blown up. And I've, like I said, I've studied that salt layer that's at the bottom of the Gulf of Mexico because it's critical to what I do in finding oil there.
Right.
But,
Oh, yeah.
But
Oh, yeah.
so trying to figure it out, and the secular models don't have a good explanation for it, but catastrophic plate tectonics does, and I'll show that next month.
Okay.
But I'm still trying to understand how 40 miles worth of rock got blown up. What's the pressure, and why was it not just water shooting up rather than all the rock in those inland seas?
Yeah, and that's why the 8th edition is over there. You can see the 9th edition. Walt Brownie goes into a lot more of that. Because then, when he first came out with the theory, it was 10 kilometers deep, because that explained the sediment on the continents. And then he went into 10 miles deep to explain the comets and the asteroids. And now he's going down to 60 miles deep to explain the trans-Neptune objects. And they think that Pluto is just billions of comets that got together. That's why it looks so pristine. And so this theory, it answers a lot of seemingly unrelated questions, and it may be wrong in a couple of them, but I think the framework is worthy of study, I would suggest. You know, if there's one theory that can answer all those mysteries that they can't answer, I would think it would be worthy of study. Oh, and I might have misspoke before. I think ICR is doing a good job. They actually invited some hydroplate proponents to come and speak at ICR. So, because they just wanted to know what other theories are out there. They should know that. You know, I wish AIG would do that, and CMI and CRS. I wish that these creation organizations would have competing models, because sometimes we get in our echo chambers and we think we're right because we don't see anything else. And that's why I'm so thankful for Frank for allowing opposing, different views to be to be compared. You know, and I have so much respect for Dr. Randy Galuza when he took over ICR. He said he'd been got advice that he should promote the ICR brand. He said, I'm not going to do that. I'm going to promote creation. And amen to that. We have to stop fighting amongst ourselves and focus on Satan and bang his head. That's what I think we ought to do.
There's a whole lot of commonalities, a lot more than there is differences between competing theories.
Yeah.
And I also think that the Bible verses have to be part of your model. And as I've shown here, the correlation between water and fountains and deep, it's almost inescapable. Those reservoirs were there. Now, how deep were they? Hey, we can talk and change that. How much water was down there? I don't know, but we can talk about that too. How high did it shoot? Did it go up 60 miles? Hey, maybe it went up 59 and a half or 39 and a half. But these are the discussions we need to have at roundtables and at creation conferences. And as more minds come together, iron sharpens iron. And out of it comes out a hybrid theory that's even stronger than either one before.
Yep.
But I suspect that the Bible favors hydroplate theory, and that's why I gravitate to it. The Bible moved me. Bible moved me. Okay?
And then as far as the stuff, even if it was really hot coming up, air is a great insulator. And this is Brian Nichols' hands right next to a 1800 degree flame. And air is a great insulator. If the stuff's going up with such force, it doesn't hit his hands. Then he's got a meet, and you can see a lot of this stuff on Real Science Radio, rsr.org. And they've got this jet engine they're testing and this berm, and it's shooting out all this heat, and yet there's snow not too far away. And so directed energy is a very powerful force as far as getting rid of the heat. So the heat won't affect you. That's just another comment.
And we're going to have more questions and answers on the third session. So
Right.
you can go home, think about it. Frank will put some of this on the internet, study it, come back to the third one, and you can have even more. But next month, we'll switch then to the catastrophic plate tectonics, and they will go through theirs and why they feel
Right.
it's the better model.
Yeah, and that's how science should be done.
Yeah.
Just have all these different theories and talk about it and critique them. But I think we've gone over it, so thank you
Okay.
for coming.
Okay.
Thank you.